It's enough to say I believe in it, but I do think that there are forms of energy that are orders of magnitude more efficient than anything we're using today.
If you have never heard of Randall Carlson, get ready to discover an incredible architectural designer, freemason, educator, geometrician, geo-mythologist, and geological explorer. He has spent more than 35 years studying the relationship between ancient secrets and modern science. Join us as we look at Randall Carlson as he reveals ancient technology that defies the laws of physics. Introduction. Ancient civilizations created astonishing technologies that challenged current understanding, ranging from advanced astronomy equipment to complex engineering feats such as the Great Pyramid. Scientist Malcolm Bendel's team identified a type of energy and tested it in a variety of contexts, including Indian Navy facilities, suggesting groundbreaking possibilities. In his interview, Randall Carlson outlined these amazing innovations, implying that old knowledge outperformed current science. Ancient civilization, impressive technology. Technology dominates the modern world, from simple objects like door handles to very complicated creations like spaceships. Without technology, you wouldn't be seeing this, and the internet wouldn't exist. It's easy to become lost in modern technology and dismiss older periods as primitive and simplistic. However, ancient technology existed, and it paved the way for many of the breakthroughs we enjoy today. Some old inventions are alarming and mysterious, while others are incredible in terms of their foresight. Buildings. Without the benefit of contemporary technology, ancient civilizations built buildings, temples, pyramids, and other structures used a variety of techniques and methods. They employed various technologies such as stone masonry, adobe or mud brick construction, timber construction, earthworks, and cyclopean masonry. These old construction methods frequently needed skilled labor, rigorous design, and hard labor. Despite the lack of sophisticated machinery, ancient civilizations were able to build amazing and long-lasting structures that have survived the test of time. Irrigation. Ancient civilizations used several types of irrigation to manage water supplies and sustain agriculture. They used a variety of techniques and systems, including canals and ditches, aqueducts, wells and bucket systems, terracing, canats, and dams and reservoirs. They were able to maximize agricultural production, support rising populations, and plant crops in areas with little rainfall or water availability by employing these irrigation systems. These old irrigation systems have left a trace in some areas even today. Metalworking. Ancient civilizations employed metalworking techniques to make tools, weapons, jewelry, artistic pieces, and other items out of metals like copper, bronze, iron, and gold. Mining, smelting, casting, forging, alloying, finishing, and decoration were some of the most frequent methods and practices used in ancient metalwork. Metalworking was critical to the technological and cultural growth of ancient civilizations, allowing them to create a vast range of utilitarian and ornamental metal artifacts. Ancient metalworkers' talents and procedures lay the groundwork for more sophisticated metallurgical practices later in history. Medical practice. Ancient civilizations used numerous types of medicines to treat illnesses, injuries, and health problems. Medical treatments in ancient cultures frequently combined empirical observations, herbal medicines, spiritual ceremonies, and early surgical techniques. While ancient medical practices varied between civilizations and areas, they shed light on early approaches to healthcare, anatomy, pharmacology, and surgery. These ancient customs affected the formation of modern medicine and are still researched and valued for their historical significance. Building of Egyptian Pyramid. The ancient Egyptian pyramids, particularly the Great Pyramid of Giza, are still considered technical and architectural marvels today. While the specific procedures utilized by the ancient Egyptians are unknown, archaeologists and researchers have presented many interpretations based on archaeological and historical evidence. While there is ongoing research and debate about the construction techniques used to build the pyramids, the ancient Egyptians combined skilled craftsmanship, meticulous planning, and innovative engineering to create these monumental structures that have stood the test of time. Tools and weapons. Ancient civilizations created a diverse range of tools and weaponry to suit their everyday needs, defend themselves, and engage in numerous activities. The sort of tools and weapons employed changed according to culture, technological breakthroughs, accessible resources, and their intended use. They perfected their talents in tool-making and weaponry, allowing them to adapt to changing environmental conditions, defend themselves against attackers, and engage in occupations such as hunting, farming, and crafting. The invention and refinement of tools and weaponry had a profound impact on ancient society's technological accomplishments. Aqueducts. Many ancient civilizations built sophisticated aqueduct systems to transfer water from its source to metropolitan areas, agricultural grounds, and other locations where it was required. Aqueducts were critical infrastructure projects that allowed civilizations to maintain continuous water supplies for drinking, agriculture, public baths, and sanitation. They contributed significantly to the growth and sustainability of ancient civilizations by providing a consistent water supply for a variety of societal purposes. These engineering wonders demonstrated ancient cultures' ingenuity, innovation, and technological prowess in the use and management of water resources. Mayan calendar. The ancient Mayan culture in Mesoamerica developed a complicated timekeeping system known as the Mayan calendar. The Mayans created several interconnected calendar systems to keep track of various time cycles, such as religious ceremonies, agricultural operations, and historical events. The Mayans employed two main calendars called the Tzolk'in and Hab. The Mayan calendar system was extremely advanced for its time and had a tremendous impact on religious rites, governance, astronomy, and daily life. It demonstrated the Mayans' profound mastery of mathematics, astronomy, and the cyclical nature of time. Chinese inventions. Ancient China was the birthplace of several ideas and innovations that not only transformed Chinese society, but also had a significant global impact. Paper, compass, printing, gunpowder, paper money, silk manufacture, and porcelain were among the most significant ancient Chinese technologies that impacted the world. These ancient Chinese inventions not only improved the Chinese people's quality of life, but also revolutionized global history, trade, technology, and culture, creating a lasting impact that can still be felt today. Reverse engineering. Reverse engineering is used to restore and preserve old artifacts and cultural heritage by analyzing, recreating, and repairing historical objects using modern technologies and procedures. This method is widely used in the conservation and restoration of ancient artifacts, artworks, and historical locations to maintain their lifespan and cultural significance. In this context, reverse engineering is used in a variety of ways, including the use of 3D scanning and imaging technology to digitally record and document artifacts and cultural heritage sites. This digital data serves as a resource for conservation efforts and enables virtual reconstructions. Conservators can employ techniques like X-ray fluorescence and infrared spectroscopy to assess the composition and condition of materials used in artifacts. This information directs restoration efforts by identifying appropriate cleaning procedures and repair materials. Reverse engineering allows the rebuilding of damaged or destroyed objects and monuments by digitally reproducing missing components or creating reproductions with 3D printing or traditional handicraft techniques. Advanced engineering technologies such as finite element analysis can be used to mimic the structural behavior of historical structures or artifacts, ensuring their stability and safety during the restoration process. Conservators can use reverse engineering to create personalized conservation strategies, analyze potential dangers during restoration operations, and apply preventive actions to protect cultural heritage items. Digitally rebuilt artifacts can be utilized for teaching, public outreach, and virtual displays, providing greater access to cultural heritage and historical knowledge. Reverse engineering is critical in the restoration and preservation of historical items and cultural heritage because it combines conventional conservation approaches with modern technologies to protect and celebrate our common history and cultural treasures for future generations. Interview with Joe Rogan. Randall Carlson is well known for investigating theories about ancient, advanced technologies, architectural feats, astronomical knowledge, and the possibility that lost civilizations possessed sophisticated scientific understanding. His arguments frequently focus on the possibility that ancient civilizations had access to information or technologies that approached or even surpassed present scientific capabilities in certain areas. Randall Carlson explored ancient technologies in his conversation with Joe Rogan, including advanced engineering skills used to build the Great Pyramids, sophisticated astronomy instruments, and forgotten information that might have competed with modern science. He underlined how these old technologies could provide new insights into our historical and technological evolution. Randall. About plasma. Randall Carlson mentions plasmoid technology in certain interviews, describing it as an advanced ancient technology that could be rediscovered today. He says that plasmoids, which are coherent structures of plasma and magnetic fields, have the potential to revolutionize energy generation, implying that ancient civilizations understood these principles. Carlson underlines the pioneering technology's potential for modern applications. He proposes that ancient civilizations may have known about and exploited advanced technologies such as plasma. For example, the precise slope angle of the Great Pyramid of Giza could imply a knowledge of energy movement and natural forces. This information might have permitted the creation of structures that effectively used natural energy. Graham Hancock compares the current state of plasma technology to the early days of electricity, emphasizing that, just as electricity transformed the world once its potential was realized, plasmoid technology has the potential to revolutionize energy generation and utilization soon, highlighting the untapped possibilities of this advanced field. Mystery of moving massive stones. Scientists, archaeologists, and historians have debated and speculated extensively about the technology and methods employed by ancient civilizations to build gigantic structures, such as pyramids, temples, and megalithic sites. While there are different explanations and speculations, scholars generally agree that ancient people built these structures using advanced techniques as well as manual labor. Scientists think that ancient civilizations, including the Egyptians, Greeks, Romans, and Mayans, used advanced engineering techniques like precision masonry, surveying, and architectural design to build their gigantic structures. Examples include accurate stone cutting, astronomical alignments, and sophisticated mathematical calculations. Archaeological data, experimental archaeology, and reliefs portraying construction scenes all indicate that ramps and levers were essential tools for moving enormous stones and building tall structures. While equipment such as chisels, hammers, and ropes were necessary in ancient construction endeavors, most agree that manual labor played an important role in the building process. Over many years, skilled stonemasons, workers, and craftsmen collaborated to build these amazing monuments, drawing on their skills and physical strength. The idea that ancient civilizations used anti-gravity devices or other advanced technologies is unsupported by scientific data. The consensus is that ancient builders used well-established engineering principles, human inventiveness, and hard effort to produce spectacular architectural marvels. While researchers recognize the ingenuity and skill of ancient builders, evidence suggests that these civilizations achieved their architectural achievements through practical tools, material knowledge, and organizational skills rather than speculative technologies such as anti-gravity devices. The agreement is that ancient engineering was a combination of technical methods, hard labor, and skillful craftsmanship that enabled these civilizations to build long-lasting monuments that still inspire awe and interest today. Plasma technology use. Plasma technology, or the use and manipulation of plasma, the fourth state of matter, has several uses in a variety of sectors and fields. It is used to treat, clean, etch, and modify materials in industries such as semiconductor manufacturing, aerospace, and automotive. Plasma can improve the adhesion, wettability, and surface characteristics of materials. It is used in medical applications such as sterilization, wound healing, and cancer treatment. Cold atmospheric plasma is being investigated for its antibacterial characteristics and potential use in the treatment of infections and skin problems. Plasma technology is used in nuclear fusion research, which seeks to mimic the energy-generating processes of the sun on Earth. Fusion reactors use plasma to provide sustainable and clean energy. It is also utilized in sophisticated lighting systems, such as plasma lamps and screens, to provide energy-efficient and high-quality lighting solutions for a variety of applications. It can be used for environmental remediation and waste management. Plasma procedures can help degrade dangerous compounds, purify water, and reduce harmful emissions. Plasma technology is used in many different applications, including spacecraft propulsion, aircraft protective coatings, and radar-absorbent materials. Plasma thrusters offer effective propulsion for satellites and spacecraft. Plasma technology is used in biotechnology to study cells, modify tissues, and remove biofilms. Cold plasma therapy has the potential to decontaminate medical equipment while also improving material biocompatibility. Plasma technology improves the characteristics of textiles by increasing color absorption, antibacterial qualities, and water resistance. Functional coatings applied utilizing plasma methods can increase the value of textile items. Overall, plasma technology is a versatile and powerful instrument for a variety of applications, including industrial manufacturing, medical therapies, environmental remediation, and energy generation. Plasma technology's potential for new solutions in a variety of industries is being expanded through ongoing research and advancements. Dr. John S. Foster. Dr. John S. Foster created plasma-enhanced combustion for engines, a revolutionary technology that uses plasma to improve combustion processes in internal combustion engines and gas turbines. This technology tries to improve fuel ignition, accelerate combustion, and maximize fuel economy while lowering emissions by introducing plasma into the combustion chamber or air-fuel mixture. Overall, plasma-enhanced combustion technology has significant promise for improving engine efficiency, performance, and environmental impact by optimizing combustion processes and fuel usage. Ongoing research and development in this subject aim to improve the capabilities of plasma technology for engine combustion applications. He also designed a plasma-based purification plant, which is a specialized facility that treats and purifies a wide range of substances, including water, air, and hazardous waste. Plasma technology, which uses high energy and ionized gases, has unique properties for breaking down impurities and pollutants via chemical reactions and physical processes. Plasma-based purification systems provide a versatile and efficient method for treating a wide range of waste, pollutants, and contaminants. By using plasma technology's unique characteristics, these plants can provide effective and long-term solutions for environmental remediation, resource recovery, and pollution control in a variety of applications. These inventions demonstrate plasma technology's potential to improve industrial applications and promote cleaner, more sustainable practices in a variety of sectors. Thunderstorm generator. A thunderstorm generator is not a commonly used or acknowledged device or technology in meteorology or atmospheric research. Thunderstorms are natural meteorological phenomena that occur when warm, moist air rises quickly, cools, and condenses, resulting in cumulonimbus clouds, lightning, thunder, and rain. Thunderstorms serve an important role in the Earth's water cycle, causing extreme weather events including hail, powerful winds, and tornadoes. While humans lack the technology to generate thunderstorms on command, there have been studies and trials into cloud seeding techniques to increase precipitation in clouds for weather modification objectives. However, these strategies aim to increase rainfall rather than cause thunderstorms. In popular science fiction or hypothetical situations, the concept of a thunderstorm generator may be employed as a story device or inventive technique for creating or controlling artificial thunderstorms. Thunderstorms are complicated natural phenomena influenced by atmospheric conditions and interactions, and their production cannot be controlled by a man-made technology. Plasma-assisted combustion. Plasma-assisted combustion is a method that uses plasma to improve combustion in internal combustion engines, gas turbines, and other combustion systems. This technology improves fuel economy, lowers emissions, and optimizes combustion stability by infusing plasma into the combustion chamber or fuel-air mixture. Plasma discharges can produce high-energy electrons and reactive species, resulting in faster and more reliable ignition of the air-fuel combination in the combustion chamber. This results in more steady combustion and higher engine performance. Plasma can encourage rapid flame propagation and help to increase flame speed within the combustion chamber. This leads to faster and more complete combustion of the fuel-air mixture. Plasma-assisted combustion can improve fuel efficiency by boosting complete combustion, minimizing unburned hydrocarbons, and optimizing the fuel-air mixing process. Plasma technology reduces undesirable pollutants like nitrogen oxides and particulate matter by allowing for cleaner and more efficient fuel burning. This reduces pollutant emissions and improves environmental performance. Plasma-assisted combustion allows engines to run more effectively with thinner fuel-air mixes. Plasma technique improves combustion stability and efficiency, allowing for leaner fuel usage, potentially resulting in lower fuel consumption and emissions. Plasma technology improves combustion stability by strengthening flame stability, permitting reliable ignition and increasing thermal efficiency within the combustion chamber. This results in smoother engine functioning and improved performance. Plasma-assisted combustion technologies are a viable way to optimize engine combustion processes, increase fuel efficiency, and reduce pollutants. Ongoing research and development in this sector aim to improve the capabilities of plasma-assisted combustion for a variety of engines and applications. Indian Navy Admiral involvement. In an interview, Randall Carlson claimed that a retired Indian admiral flew from India to take part in sophisticated technology testing. This involvement demonstrates the global interest and collaboration in researching and validating groundbreaking ideas, emphasizing the significance and potential effect of these new technical advancements. The Indian Navy is interested in incorporating these breakthroughs into naval operations, highlighting the worldwide collaboration and potential influence of these groundbreaking advances on military and defense operations. Reduces harmful emission. According to Randall Carlson, prior to plasma technology, generators emitted toxic gases such as carbon monoxide, nitrogen oxides, and particle matter, which contributed to air pollution and environmental damage. Carbon monoxide is created by incomplete combustion of fuel and a lack of oxygen. Automobiles are thought to account for over 90% of CO emissions, and among the different gases generated, CO emissions were the first to be controlled. When inhaled by humans, this gas causes a hemolytic reaction, which leads to poisoning. However, diesel generators have more thorough combustion than gasoline engines. Therefore, the amount of CO produced is much lower. Nitrogen oxides refer to a group of chemicals that include NO, N02, N20, and N202. It is created by combining nitrogen and oxygen molecules at high temperatures. In addition to automobiles, cigarettes and stoves emit NOx. The higher the combustion temperature, the easier it is to emit NOx. As a result, while designing a diesel engine, the combustion temperature must be adequately reduced. Particle matter is a broad term for particulate matter generated by diesel engines, primarily soot. It is made up of the residual fuel and lubricant components after combustion, as well as the components produced by sulfur combustion in light oil fuel. This is why Carlson emphasized the cleaner environmental benefits of plasma technology, as well as the increase in oxygen levels caused by its use. How plasma technology was used in ancient times. Randall Carlson has noted that ancient civilizations had advanced technologies equivalent to modern developments, implying that they had knowledge like today's technology. He emphasizes the ongoing efforts to comprehend and duplicate these old technological achievements. Ancient civilizations may have interacted with plasma in its natural state, and it is plausible that they saw phenomena such as lightning or the color-changing capabilities of specific fires. However, the deliberate use of plasma technology as we know it now would not have existed in ancient times. Khufu Pyramid. According to Randall Carlson, the builders of the Great Pyramid of Giza may have been excellent architects and engineers rather than modern-day mathematicians or physicists. They possessed a thorough understanding of geometry, astronomy, and engineering principles, enabling them to design and build such spectacular structures. When building the pyramids, they used a slope angle of 51.83 degrees, suggesting a strong awareness of geometry and their surroundings. They might use these constructions to generate energy. While their work utilized mathematical principles and accurate measurements, it's worth noting that they probably did not approach their profession with the same codified disciplines that we do today. To construct structures such as the Great Pyramid, ancient Egyptian builders relied on practical knowledge gathered over decades of trial and error. Their mastery of these practical abilities enabled them to accomplish extraordinary architectural feats without relying on advanced mathematical or physical theories. Vortex. A vortex is a fluid flow pattern defined by a swirling motion around a central point. Tornadoes, whirlpools, and dust devils are examples of natural phenomena that exhibit vortices, in which the fluid revolves around an axis. Vortices can also be artificially generated or harnessed for a variety of purposes. For example, in engineering, vortex generators are used to manipulate airflow across surfaces to reduce drag or increase lift in airplanes. Vortices serve an important role in understanding fluid behavior in motion. Overall, vortices are intriguing patterns that appear in both natural and man-made systems, displaying the complexities and dynamics of fluid motion. Vortex technology in pyramids. The Great Pyramid of Giza, at 51.84 meters tall, is thought to harness vortex energy due to its precise design. Its geometry concentrates natural energy from the soil and environment, which could power lights and tools. Some believe the interior may have therapeutic properties due to vortex energy. Ancient spiritual practices imply significant technological knowledge, pointing at unexplored applications for these structures. Further investigation may reveal new insights into both old technology and spiritual understanding. While pyramids have been the subject of numerous ideas and speculations about their potential uses and purposes, the concept of vortex technology in relation to pyramids is not supported by mainstream scientific understanding or archaeological data. It is crucial to examine such claims with skepticism and look for credible sources and proof to back up any outrageous claims. The study of ancient structures such as pyramids is a fascinating field that relies on archaeological data, historical context, and scientific analysis rather than fanciful or pseudoscientific conceptions such as vortex technology. Public demonstrations. Randall Carlson publicly showcases antique technology at numerous conferences. These demonstrations help visitors grasp the advanced knowledge and techniques used by ancient civilizations. Indian Navy. Randall Carlson publicly shows ancient technologies, notably to the Indian Army, which is investigating these tactics to safeguard its vast coastline. Their ships and submarines already consume significant amounts of oil, resulting in pollution that threatens marine wildlife and water quality. By implementing this technology, the Indian Army hopes to reduce fuel consumption, save money, and reduce environmental effect, strengthening both defense and sustainability initiatives. Different industries. Public displays of technology have transformed several businesses, lowering pollutants and increasing manufacturing efficiency. By demonstrating these methods, more people became aware of their potential. This understanding has enabled industry to adopt cleaner, more efficient processes and increasing output while reducing environmental impact. Alchemy science. The Sean Ryan Show covered alchemy science, including its ancient origins in Egypt, China, and India. Alchemy, a combination of philosophy, mysticism, and early chemistry, sought to convert basic materials into noble ones, such as lead to gold. Transmutation is the process by which protons and electrons alter their electronic state and move. During transmutation, protons and electrons are rearranged to change an element's atomic structure and characteristics. This indicates that technology was influencing the atomic structure of materials at ambient temperature. Application of transmutation. Transmutation is the process of converting one chemical element into another by changing the number of protons in the atomic nucleus. Although transmutation is a fundamental idea in nuclear physics and chemistry, it has few practical uses in controlled environments. Nuclear power facilities use transmutation processes to change certain isotopes of elements into more stable forms via nuclear reactions. This aids in the management of radioactive waste and improves the efficiency of nuclear fuel. Transmutation procedures are utilized in nuclear medicine to produce radioisotopes that are useful in diagnostic imaging and cancer treatment. Transmutation can also be used in scientific research, such as producing rare isotopes to examine nuclear properties or doing elemental analysis. Overall, while transmutation has vital applications in domains such as nuclear power and medicine, it is a difficult process that necessitates modern technology, as well as careful consideration of safety and ethical concerns. Disadvantages of transmutations. Transmutation has significant drawbacks, including high energy costs and possibly radioactive waste. Its intricate procedures may pose environmental risks and safety problems. The technology demands significant investment and skill, which limits its accessibility. Conclusion. To address the obstacles of transmutation, teamwork among physicists, chemists, and engineers is required. They may address worries about radioactive waste by pooling their expertise and developing safer, more cost-effective alternatives. This interdisciplinary approach will progress transmutation technology by ensuring that the advantages outweigh the negatives, paving the door for long-term advancements. It's clear that ancient civilizations have contributed a lot to modern civilization, even though they had limited resources and knowledge. What is your opinion on this matter? Why don't you let us know in the comments below? Well, that's it for now. I hope you enjoyed this video. Please give us a like and let us know in the comments what you think. Check out our other videos and subscribe to be part of the fun. Click on the notification icon so you can see our new videos as soon as they're uploaded. Thank you for watching and see you next time.